Hi 301, today I'll be going through your Redox worksheet 1 and 2. Okay, so here we are actually given a list of substances, and we actually tasked to determine whether it is being oxidized or reduced based on the gain or loss of oxygen and hydrogen. Okay, so let us look at question 1 part A. Okay, observe that for zinc, it actually gained oxygen to form zinc oxide, while lead 2 oxide lost oxygen to form lead. Okay, so we can just simply deduce that zinc was being oxidized because it gains oxygen, and lead 2 oxide actually was reduced because it loses oxygen. So for part B, similarly, we can deduce that carbon monoxide has actually gained oxygen to form carbon dioxide, so it is oxidized. Whereas for iron 3 oxide, it has been reduced to form iron, and it loses because it lost oxygen. For part C, lead 2 sulfide has actually gained oxygen to form lead 2 sulfate, and it's being oxidized. While for hydrogen peroxide, it was reduced because it lost oxygen to form water. Okay, so for part D, here there's actually no oxygen that was present, so in this case we'll actually look at it in terms of hydrogen. So for methane gas, it actually it actually lost hydrogen to form chloromethane. So it loses hydrogen, therefore it was being oxidized. Then let us look at chlorine gas. Chlorine gas it actually gained hydrogen to form hydrogen chloride gas. So in this case it's being reduced because it has gained hydrogen. Okay, so here for part A and part B, we are actually tasked to explain whether which substance was being oxidized and which is being reduced in terms of oxygen. So here, if we look at zinc, it actually gained zinc was actually oxidized because it has gained oxygen to form zinc oxide. Whereas copper 2 oxide was being reduced because it has lost oxygen to form copper. Next, for iron 3 oxide, the reaction between iron 3 oxide and carbon monoxide, the substance that was oxidized was actually a carbon monoxide to form carbon dioxide gas because it has gained oxygen atoms. And iron 3 oxide is being reduced because it has lost oxygen to form iron. So next, looking at this equation here, methane gas reacts with chlorine gas to form carbon solid and hydrogen chloride gas. So we are required to explain in terms of hydrogen. So you can actually say that methane gas is being oxidized because it has lost hydrogen to form carbon, and chlorine gas, Cl2 gas, is reduced because it has gained hydrogen to form hydrogen chloride gas. And then your concluding statement will be that since that methane is being oxidized and chlorine gas is being reduced, the reaction is a redox reaction. Okay, so for the next question here, question 4, just remember this acronym, Leo and Ger, where loss of electrons is oxidation while the gain of electrons is reduction. So based on all the half equation here, you determine whether the substance has actually lost electrons or gained electrons, then you can determine whether it's an oxidation and reduction reaction. Okay, so for the half equations, do take note of that we cannot have minus electrons appearing in any part of the equation. So if it's a loss in electron, we actually shift the minus electron over to the other side of the equation. Like for example, for this Fe2 plus of this Fe2 plus ions when it form Fe3 plus ion. Okay, so do take note for oxidation half equation, the substance has actually lost electron, while for the reduction half equation, the substance has gained electron. Okay, and do take note of the state symbols as well. Okay. Okay, so for the last part of this redox worksheet 1, in terms of electrons transfer, do take note that for in the substance, we actually break it down into their respective ions. So here for nitric acid, I actually broke it down to its ions, H plus ion and the nitrate ion. And for zinc nitrate, the product, we split it into the zinc 2 plus ion and the nitrate ion. So from here, we can actually observe that the zinc metal has actually lost 2 electrons to form zinc 2 plus ions, because each zinc atom has actually lost 2 electrons. Whereas for nitric acid, you realize that 2 H plus ions actually gain 2 electrons to form our hydrogen gas. So it will be a complete transfer. The number of electrons that was transferred from the zinc to nitric acid is the same. So one zinc atom lose 2 electrons, while 2 H plus ions gain 2 electrons. Then do remember your concluding statement. Since zinc is oxidized and nitric acid is reduced, the reaction is a redox reaction. Okay, so let us move on to the last 2 questions. Okay, so from here, similarly for your silver nitrate solution, we split it into the silver ion and the nitrate ion. Whereas for the product, split the copper nitrate into its copper 2 plus ion and the nitrate ion. So from here, you can realize that copper is actually oxidized, as each copper atom has lost 2 electrons to form the copper 2 plus ions. Then silver nitrate is actually reduced because each silver ion has gained 1 electron to form a silver atom. Then since we actually prove an oxidation and a reduction, both oxidation and reduction reaction in this chemical reaction, so you just explain that since copper is oxidized and silver nitrate is reduced, the reaction is a redox reaction. So lastly, for the reaction between aqueous bromine and aqueous potassium iodide, we will split the potassium iodide solution into its ions. So the potassium ion and the iodide ion. Then for the product, potassium bromide, we split it into the potassium and bromide ion. So from here, we can actually realize that aqueous potassium iodide was being oxidized, as 2 I minus ions actually lost 2 electrons to form iodine, aqueous iodine. Whereas for aqueous bromine, it was actually reduced, as each Br2 molecule gained 2 electrons to form oh sorry, this one shouldn't be I minus ions, it should be Br minus ions. Okay, so since potassium iodide is oxidized and aqueous bromine is reduced, the reaction is a redox reaction. Okay, so now let us move on to redox worksheet 2 on oxidation states. So do take note for elements in group 13 to group 17, excluding oxygen and fluorine, all the elements there are actually capable of having positive or negative oxidation states. Okay, so in this case of nitrogen, you can see nitrogen is capable of having oxidation states that vary greatly, and it can be negative or positive. Okay, so for ammonia, the first example 1A, we treat the oxidation state of H to be +1 if it's not being bonded with any metals in a compound. H will always typically, in 95% of the time, H will have a oxidation state of +1 inside compounds. So from here we can deduce that the oxidation state of nitrogen in ammonia is just -3. Okay, so next example, nitrogen monoxide, oxygen will have an oxidation state of -2 also in 95% of the time inside compounds. So the oxidation state of nitrogen can just be determined to be +2 inside in for part B. Then for part C and D, we just take the oxidation state of oxygen to be -2 as well. So do take note for part D, there's actually a charge. The ion actually has a charge. So the sum of all the oxidation states of all the atoms will actually be -1. So from here we can actually deduce that for C it will be +4, and then for D it will be +5. Okay, so for 2A, B, C, D, E, F, I think based on the logic, you should be able to deduce all the oxidation states. So please check your answer accordingly. Okay, so for the naming convention, do take note we actually use Roman numerals. So we actually attach the oxidation state of the transition metal in the form of a Roman numeral at the end of the name. So here if we have V2O5, it's just vanadium in oxidation state of +5. So vanadium bracket V oxide. And for nickel, oxidation state of +2. So nickel bracket 2 hydroxide. Then for titanium chloride, is titanium bracket IV for representing the +4 oxidation state chloride. Okay, so let's move on to the writing of statements of oxidation using oxidation states. So this portion is this is actually a very important thing that we have to do it properly for this chapter, because oxidation state is actually the main the most important tool in actually trying to determine redox reactions. So we actually have to justify it properly in the form of statements. Okay, so for part A, for tin 2 plus, SN2 plus is actually tin 2 plus ion reacts with 2 Fe3 plus ion to form Fe2 plus ions and the SN4 plus ion. So as we can see, based on all the charges here of the ions, we can actually just determine the oxidation state directly from it. So it will be +2, +3, +2, and then +4. So SN2 plus is oxidized as the oxidation state of tin increases from +2 in SN2 plus to +4 in SN4 plus. So all your statements here, do take note, explain which substance is being oxidized or reduced, and then explain that the oxidation state of the element increases or decreases from how many in the reactant to how many in the product. So always follow this format, okay, when writing your statements. Then for part B, just split all the individual atoms up into their oxidation states. We can actually observe that oxidation state of O in H2O increases from -2 to 0 in O2. So H2O was being oxidized, while for fluorine gas was actually reduced because the oxidation state of fluorine decreases from 0 in fluorine gas to -1 in hydrogen fluoride. Okay, so for part C, similarly break all the atoms up into their individual oxidation states. You will realize that oxidation state of sodium increases from 0 to +1, so it is being oxidized. So 0 in sodium metal to +1 in sodium hydroxide. Whereas for water, the oxidation state of hydrogen decreases from +1 in water to 0 in hydrogen gas, so it is being reduced. Okay, so for part D, it will be interesting because actually we can actually compare the oxidation state of oxygen, right, in both carbon dioxide and water. So okay, for oxidized substance, it will be your methane gas, because the oxidation state of carbon increases from -4 in CH4 to +4 in CO2. However, for O2, we can actually justify why it is being reduced, because it decreases from 0 in O2 to -2 in CO2 and H2O. So for this portion, we can actually write the oxidation state of oxygen in carbon dioxide and water, both -2. Okay, so if you want, you can write either CO2 or H2O, or you can just write both CO2 and H2O. Okay, so for part E, just speed up into their individual oxidation states as well. So you will realize that iron has an increase in oxidation state from +2 to +3, whereas for chlorine the oxidation state decreases from 0 to -1. So do take note, write your statements from how many in which substance to how many in the reactant to how many in the product. So FeCl2 is being oxidized because oxidation state of iron increases from +2 in FeCl2 to +3 in FeCl3, while for Cl2 is being reduced because oxidation state of chlorine decreases from 0 in Cl2 to -1 in FeCl3. So for the last part of this exercise, okay, this one I think is the most is the toughest example out of all 6. So here we'll be actually looking at lead-2 sulfide reaction with hydrogen peroxide. So here we just split lead-2 sulfide into its respective oxidation state. We should obtain lead actually has +2, and for the sulfide ion is -2. Then for hydrogen peroxide, split it into hydrogen and oxygen. So in this case, right, hydrogen peroxide is actually an exception where oxygen does not exist in the oxidation state of -2. Instead, it is -1. Because for H2O2, the reference point here will be for hydrogen. Hydrogen will have the oxidation state of +1 here. Okay, so from here, oxygen actually exists as -1 oxidation state, and we can actually observe that oxygen's oxidation state actually decreased from -1 to -2. So we can determine that hydrogen peroxide was being reduced because oxidation state of oxygen decreases from -1 in hydrogen peroxide to -2 in lead-2 sulfate and water. Because in lead-2 sulfate, the sulfate ion, sulfur has an oxidation state of +6 and oxygen will have oxidation state of -2. So how do we justify that lead-2 sulfide has been oxidized? So we can actually observe, if you realize, right, the oxidation state of lead is +2 in both cases. So in this case, we cannot use lead as the reference point to justify the oxidation. So maybe let us look at sulfur instead, because you will realize that sulfur actually increased from -2 in lead-2 sulfide to +6 in lead-2 sulfate. Okay, so here do not look at lead, but look at sulfur instead. So we are comparing the oxidation state of sulfur and oxygen in this reaction. Okay, so let us look at question 5. We can actually determine that magnesium is oxidized in 3 different methods, right? We have learned gain or loss in oxygen and hydrogen, gain or loss of electrons, and increase or decrease in oxidation state. So here the first method is to use oxygen, which I think is the easiest method to justify, because magnesium is oxidized as it has gained oxygen to form magnesium oxide. And we can also explain it in terms of electrons. It's being oxidized as each magnesium atom has lost 2 electrons to form Mg2+ ions. Then lastly, for oxidation state, we can say that magnesium is oxidized because oxidation state of magnesium increases from 0 in magnesium to +2 in magnesium oxide. Okay, so for question 6, we are actually given this word equation. So for word equations, typically I would highlight the various substances that are being present, and then we will write them out in a chemical equation form. Then from there we will balance the equation. So we should be able to obtain this equation here where copper 1 oxide actually reacts with sulfuric acid to form copper 2 sulfate, copper metal, and water. So all the stoichiometric coefficient is 1 in this reaction. So for part B, they are asking you to discuss the change in oxidation state of copper. So if you realize from copper 2 oxide to copper 1 oxide to copper 2 sulfate, the oxidation state of copper increases from +1 to +2. However, do realize that in addition, right, the oxidation state of copper also decreases from +1 in copper 1 oxide to 0 in copper. So actually copper in this case has obtained two different oxidation states in the products. So in part C, they're asking you whether it's being oxidized or reduced. So actually, in a way, we have already justified it in part B. So it's simply just a repeat of what that was explained. And then there's actually the concluding statement that you have to make. Therefore, because we have shown that copper 1 oxide has actually obtained two different oxidation states, is being both oxidized and reduced in this reaction. So we can actually conclude that at the end, copper in copper 1 oxide is both oxidized and reduced in this reaction. So in part D, this reaction is called a disproportionation reaction. Then try to deduce one characteristic. So actually you already concluded that copper in copper 1 oxide is being both oxidized and reduced. So actually you have already, in a way, obtained the definition of a disproportionation reaction, which is simply that a substance actually undergoes both oxidation and reduction simultaneously during the reaction. So when actually this occurs, we can actually deduce that, just conclude that this reaction is a disproportionation reaction.